Hello, everyone. Welcome to the Dome9 webinar this morning, the case for security automation in the cloud. We're going to give people a few more minutes to join. I'm going to put you on hold and bring you back in 2 minutes. Thank you. Hello, everyone. Welcome to the Dome9 webinar, the case for security automation in the cloud. My name is Thelen Blum. I'm the Senior Product Marketing Manager at Dome9, and I'm here with Patrick Pusher, Director of Customer Advocacy for Dome9 Security. In 2015, there were 781 publicized cybersecurity breaches, which resulted in more than 169 million personal records being exposed, a number that's steadily on the rise year over year. Yet only 38% of organizations across the globe can confidently say they are prepared to handle a sophisticated cyber attack. Managing security in the cloud requires a new breed of tools that combine automation with continuous monitoring and active protection. In the 60-minute webinar, we will showcase how the Dome9 Arc platform leverages cloud-native security controls and cloud-agnostic policy automation to enable comprehensive network security, advanced IAM protection, and continuous compliance for AWS, Azure, and Google Cloud Platform environments. Dome9 offers technologies to assess security posture, detect misconfigurations, model gold standard policies, protect against and identity theft, and conform to security best practices in the cloud. We will close with Q&A at the end of the session. A couple of housekeeping notes before we get started. This webinar is being recorded and will be made available afterwards. All attendees are in listen-only mode. If you would like to ask a question, please type it in the questions window of GoToWebinar, and Patrick will address as many questions as possible, time permitting. We also have a copy of some of Dome9's product and feature briefs, which include the Dome9 Arc platform, Dome9 IAM Safety, the Dome9 Compliance Engine, and Dome9 Clarity. Feel free to download this content at any time during the webinar. Without further ado, I will now pass the ball to Patrick. Let's get started.
Thank you, Thelen, and thank you everyone for joining us for about the next 55 minutes as we really make the case for security automation in the cloud. These days, really, every enterprise organization is a software publisher of one kind, either formally with specific named products or services, or informally via the creation of internal capabilities, and probably more importantly for our session today, software-driven automation. So, you know, the move to paradigms like continuous integration, continuous delivery, really began with the rise of popularity of the agile software development methodology. Once we moved from big monolithic software releases, often published as box products and shipped to physical stores, to much smaller incremental software releases on a more continuous basis, we shifted to deliver this software, in many cases, even as Dome9 does, as a service. We required new perspectives on how we consume and control infrastructure, and then right behind that, how we manage security in this new paradigm. So, it's really those organizations then who can marry together an agile software methodology together with an infrastructure that can respond at the rate of change that they require, that will find ultimate success in their pursuit for efficiency. DevOps then is the intersection of software development and infrastructure operations that results most often in a unique blend of automation and integration to enable a mix of development, testing, QA, and release teams to be part of a single approach to problem solving, right? And we break down those functional silos between these groups, and we view them as one while we integrate the output of one process to the input of another. What often gets considered last, or even in extreme situations, sometimes not at all, unfortunately, then is security. And so when we re-architect our development process to be more agile, but we leave security out of the discussion, we wind up in a state where we do security validation at the very end of this process, right, just before we deploy our solution. And the challenge with this is the investment in time that process has already consumed, right? Wouldn't we want to know much earlier in that process, if possible, that our solution, failed our internal security checks? Of course we would. It's one of Agile's most main tenets, really, isn't it? Fail fast so you can course correct and get it right, rather than invest much more time in a process that will ultimately fail in the end anyways. So once again, security becomes that sort of red-headed stepchild, if you will, that's viewed as something an organization must do, rather than considering security as an enabler of new capability, for example. So in comparison to that traditional and siloed approach, we see that rugged DevOps scenarios integrate security into each step of the software development lifecycle by leveraging automation and integration between technologies. We need automated methods to understand, if, when, and how changes to our environment deviate from our desired state. From a people perspective, we also integrate security staff, engineering, and operations together for a unified and an always current perspective on infrastructure needs versus security visibility and enforcement. So Dome9 is a software as a service delivered security orchestration platform that can be used both interactively, but also pragmatically in a heavily automated fashion via the Dome9 API. Dome9 is no different in this regard than the infrastructure as a service platforms that it supports themselves, right? Anything you can do at the interactive console, you can accomplish via API with Dome9. And the platform is purpose-built this way to fit the needs of those migrating from a traditional data center environment where automation is modest and will heavily lean on the respective console, the infrastructure as a service console, all the way up to those already heavily invested in AWS Azure or GCP API in the way of automating their infrastructure needs, and they need tooling to fit into an already existing workflow or process. And the Dome9 ARC family stands for Assess, Remediate, and Control, the three pillars of really functionality within the platform. We have tools and perspectives to deep dive into either live cloud networking scenarios or to infrastructure as code to assess for security posture. Once understood, Dome9 has the capability inline to fix problems identified by this new visibility without even leaving the tool, and then the ability to enforce the correct configuration going forward, and to regularly assess your overall security posture compared to any desired baseline, even a very customized one. So today in this webinar, we will review just a few of the Dome9 capabilities that speak to the heavily automated management of your security posture, but there are many related features within the Dome9 ARC platform. From IAM-based privilege credential protection to dynamic access leasing, which is a just-in-time based access to sensitive network services. Each Dome9 capability plays a part in increasing your level of visibility required to make informed security decisions. So think of the capabilities we'll speak of shortly as a part of a bigger family that delivers the visibility and control required to scale your security alongside the rest of your cloud efforts. But just before we go there, let's close on what a rugged DevOps-enabled scenario might look like. So, validate your security and compliance posture earlier in the process. We talked about that a few slides ago. The earlier, the better. We do this in two ways. One, with a feature called Dome9 Clarity, where we can evaluate in a Visio diagram-like fashion where traffic can, and perhaps more importantly, cannot flow within a given cloud network. The second way is involving Dome9 via API to compliance test our efforts early. And don't let that compliance word kind of throw you off. It's not just for external data security standards, right? This is for whatever is important organizationally to you from a security perspective. And then no more full-time open network security ports to accommodate the software deployment process, right? Using Dome9, if we have time, I'll show you how to keep your closed by default security posture, but still enable the push of software through the software development lifecycle kind of in an on-demand way. And if you're tired of alerts from sort of so-called automation software that don't make sense for your organization, too many assumptions, maybe those alerts are too generic, we'll show you how to focus in on exactly what's important to you, and really only that via Dome9's compliance and governance feature set. So with that, let me pivot over to the product itself. Okay, welcome to the Dome9 dashboard, and we're going to look at, as mentioned already, we're going to look at a few core capabilities, and we're going to start with the compliance engine. So you'll find that under the compliance and governance menu, the compliance engine. So I think as we positioned earlier, the compliance engine is both for those organizations that are mandated, regulated to follow a specific compliance standard, and or those who are really just looking to build a set of rails, if you will, to judge their overall infrastructure as a service efforts against whatever's really important to them. Maybe they are interested in proving to stakeholders at large that security is important and taken seriously. So whether you're governed by formal standards like PCI, HIPAA high-tech, or you're following less structured but just as important standards like the CIS benchmarks, or even the best practices tied to the infrastructure as a service platforms we support. And I should mention those are AWS, Azure, and Google Cloud Platform. Whether you're sort of formally governed or you're looking for one of these best practice, best of breed sort of standards, Dome9 has you covered. And you'll notice above this gray line that I'm highlighting here, these standards are pre-published by Dome9, and so they're not something that you have to sort of author on your own. They're consumable off the shelf as soon as you start with Dome9, and that gets you a long ways. So when you first onboard your Dome9 account, you're doing so by building a policy within the respective platform, and then having Dome9 sort of attached to that policy. You are not loading in agents or appliances into your environment. Everything that Dome9 does is done by deep API integration into those platforms we support. So all that to say, as soon as you get started, you can be very, very fruitful, within 5 or 10 minutes of beginning your Dome9 account. So what I might do then is to choose one of these off-the-shelf standards, and we'll select PCI. It's got a nice round number of about 76 different measurements. And you can see on the right-hand side the kinds of things that this, we call this a rule bundle, evaluates for us. Things like, are we logging in and using the root account, which is definitely not a best practice? Do we have the appropriate logging turned on our respective cloud platform? Do we have and are we enforcing a password policy across all users of that platform? As well as some of the more traditional checks that you might expect, things like over permissive port access policies, S3 bucket permissions. Do I have any wide open S3 buckets? I think Thelen did a good job introducing the webinar today around some of the data exposure events we've read about as of late, and S3 buckets seem to be on the top of that list. Even things like key rotation within the KMS service at AWS. So I'm going to take this rule bundle and I'm going to run it. Now, as I do, you'll notice that I can do this against a live environment, or I can do this against a CloudFormation template. And that's a really important part of the discussion as we think about fitting the capabilities of Dome9 into existing processes, right? We talk about the ability to express our intent through infrastructure as code. And this is one of the ways that Dome9 gets involved in the process much earlier than after you provision infrastructure. What a lot of our enterprise customers are doing is getting Dome9 involved much earlier, such that we can take a look at that infrastructure as code in the way of a CloudFormation template, evaluate it against the same criteria you use to evaluate your live environment. If it fails, send it back to the peer review process, understand why it failed, retool that CloudFormation template, and send it through the process again. And in that way, by the time it actually reaches live infrastructure state, you can be assured that it does conform to all of your governance standards versus provisioning it, evaluating it, then if there's a problem, tearing it down and sort of going through that iterative cycle. So for now, we're going to do this against a live environment, but we'll probably come back a little bit later and do this against a CloudFormation template as well, and we'll exercise this PCI rule bundle. Now, the resulting report is really intended for two different audiences. The top of the report is really more of a compliance officer, aggregate view of all of the checks we did, our overall pass-fail ratio, where we failed, kind of how we did by severity, the different kinds of checks we ran. We did a fair number against security groups, a fair number against instances or virtual machines, and then and so on and so on. Some more against identity and access management users. And then geographically, we also break down the testing we did per region. So here in this region, I can see that I did quite a bit better than my overall pass-fail ratio. Maybe that's, that should be part of my sort of gold standard. I should model what I did there, maybe globally. But then the bottom half of the screen is really more of that practitioner perspective, right? Kind of the results of each check, and kind of positioned for the individual or team that'll be tasked with going and fixing these problems. And so, for example, here's a traditional network security example where, I'm making sure, and let's look with this one here, I'm making sure that there are no security groups, my firewall as a service, if you will, that allow very broad traffic into a sensitive service like SSH. And I can see out of 223 tested security groups, I have 12 that failed, or that did have, kind of any rules associated with Secure Shell. So to hit expand, I can see exactly which of those security groups these 12 failures are. And so this is where Dome9 deviates quite a bit from competitive solutions, whereby we do quite a bit more than just share with you information. We give you sort of a path to resolution as well. So out of this list, if I click on any of these, I'm going to click on this default security group. First of all, if I see a default security group show up in this list, I know I'm really breaking, maybe more than one best practice. I know that the default security groups that are associated with AWS and the other platforms really, as a best practice, shouldn't be leveraged. They shouldn't have rules in them, and they shouldn't have resources assigned to them. So, just by virtue of seeing them show up in this list, I know that they do have not only rules in them, but they have a really permissive rule in it. So I'm going to visit this one, default. And when I click on it, you'll see that I can open up this security group in its own dedicated tab, and now I have the ability to manage it right from Dome9. I don't have to bounce over to the respective platform. In this case, it's AWS, and sort of have two different control planes. I can do this all within Dome9. So in this case, it's this overly permissive SSH rule. I can either edit it from here, limit the scope rather than being open for everybody. I can limit it down to a specific IP, for example. If it's an erroneous service in the first place, or doesn't need to be here, I could delete it entirely. Once I have this security group corrected or the problem solved, this toggle up here becomes the next really important decision to make. In read-only, this security group, Dome9 is always monitoring, kind of in a 24/7 watchdog sort of fashion, the configuration of each security group. And when something changes, Dome9 will notify you, both in the audit trail, which you can have connected to your SIM platform of choice, and via email notifications that something changed. After all, that's part of the value of the platform, is making sure that you're always aware of incoming changes to your security configuration. So that's in read-only mode. In full protection, Dome9 does the very same things, but instead of stopping at the notification side, Dome9 will actively back out any changes that are introduced to the security group that are outside of the scope of what you have listed here. So, if I delete this SSH rule, for example, and maybe somebody tries to sneak it back in at the AWS console, or maybe something, it doesn't have to be an interactive use case, maybe you go to run, the first run of a new automation script that does this, Dome9 will catch it and will actively revert it back out. We'll delete it for you, right? Because you told Dome9 that's the configuration you wanted. So read-only keeps you informed. Full protection does the same, but then it also actively enforces whatever sort of gold policy you have configured here. And that's very, very powerful. But let's say, we don't know why this is here. Trying to understand this security group configuration in isolation of the rest that it might be attached to becomes difficult. And so what we're going to do next is visualize this security group in a feature we have called Dome9 Clarity. And I can do that right here. Clarity is also, I can also get there via the top navigational menu. But to sort of follow a workflow, I mean, we found this problem via the Dome9 Compliance and Governance engine. We went and navigated to this security group itself in its own dedicated tab, where we're able to manage it and correct the problem, and optionally turn on what we call full or tamper protection. But in order to really understand the role this security group plays in our overall cloud architecture, let's visualize it in Clarity. So I'm going to click this button, and you see we have a new tab open once again. And now what you're looking at is the default security group highlighted in whatever VPC it existed in this case it's our main demo VPC. And what we've done is we've drawn out each of the security groups in this network, and we've classified them in one of these Clarity swim lanes. And so our default security group, the one of interest, showed up here in the DMZ. And it's in the DMZ because it has one or more very, very permissive rules. And we know that because it's this rule that the compliance engine found in the first place, right? It's this secure shell, a very potentially sensitive service that's open to the entire world. Now we have another security group here in the DMZ for our load balancer. That one is at least in theory, is less of a an error state in my mind than default is, because quite often it's a load balancer's job to take very broad traffic, judge it, and then optionally send it deeper into your network. But as we already mentioned, the fact that we have a default security group populated in the first place is kind of breaking a best practice. It's done so in a very permissive way, and now by looking at Clarity I can tell not only does it have a rule in it, but this number 1 tells me that it also has a resource assigned to it. So I mean, this is breaking best practices left, right, and center. And so I can see from highlighting it and looking over here in the right-hand detail pane that it's got what appears to be, by the naming convention, a database instance assigned to it. And so that's a huge no-no, and that's what Clarity is really, really good at illustrating. And you can see me kind of zooming in and out, panning around. Obviously, cloud networks get larger than this. This is a good kind of concise example, but our customer networks of Dome9's can have many resources in them in terms of a VPC configuration. So you're able to sort of pan and zoom within Clarity, but we can tell right away via the illustration that Clarity has drawn for us that this default security group is a big problem. But while we're here, let's make sure the rest of the architecture for this VPC is sound. So we do a quick check under partially open, and we see that these 4 security groups have some whitelisted access from the outside in, not nearly as permissive as the DMZ. So they'll have some whitelisted access, maybe some single IPs or small ranges, but no any kind of 0.0.0.0 rules associated with the DMZ. And then back here in the internal zone, these resources, as the name suggests, really only accept traffic from within the boundaries of this VPC, either other security groups or private hosts. So they're truly sort of considered internal. The effectively internal is a bit of a special categorization. What this means is that the security controls, so the service definitions within the security groups are potentially quite permissive. And you can see when I click on Web Monitor, again, we highlight the really permissive ones in red. So in this case, it's a wide open SSH rule, much like we found in default. So you might be asking yourself, well, if it's that permissive, why isn't it over in the DMZ like the others? It's not, because the resources assigned to this security group lack public interfaces. So said in another way, this instance here called monitoring 2 has a private IP, not a public IP. So it's effectively internal, meaning there's no public route from the outside into this resource. But as we know in our software-defined world, right, this is a click in the AWS console or an API call away from changing from a private to a public IP, and therefore becoming accessible from the outside. So it's a special category we call effectively internal, meaning for now you're safe, but you're one small configuration step away from potentially unintended data exposure. So far we've really spoken about Clarity being this Visio diagram sort of tool to understand all of the potential traffic flows within a given cloud network. You might expect all of the external sort of traffic to look like this. After all, the raw IP address information is what we use as we define security group rules within AWS, Azure, and GCP. It doesn't. You can see they kind of have English names here due to a Dome9 feature we have called IP lists. So I can build IP lists to contain IPs or IP ranges. As you can see when I click on this, I have the contents of the IP list listed on the right-hand side. And the intent of an IP list is twofold. The first is to aid in understanding. Obviously, if I just had a bunch of raw IP address information like this one, I mean, it's meaningful to an extent, but to really understand it, you may have to have beside you an IP justification spreadsheet, for example, to understand exactly who these IP addresses belong to, what business purpose they're used for, and so on. Grouping these together in Dome9 IP lists give you some immediate understandability around where traffic's coming from, as Clarity kind of renders this illustration. So for understandability is kind of the first use case. The second is security at scale, right? If I onboard another partner tomorrow and I add a 5th IP or a 5th IP range to this list, it'll propagate out to wherever I use this list. If I click on this security group, for example, and I open this in Central, much like I did to the default security group earlier, I can see that I'm using these list objects right in the definition of my services in this security group. Now, obviously, when we push this information, in this case, again, to AWS, we do so via the AWS API. We translate, the contents of these IP lists into raw IP address information. That's the format of the information that AWS expects. But under the covers, we're doing that translation so that you can use these IP list objects within your Dome9 config, and then we'll push the appropriate information that AWS expects to it via the API. Which means, again, you can maintain these IP lists with meaningful information to you, subtract an IP or a range, add an IP or a range, and have that propagate out wherever you use these objects in your policy, which again is more of a security at scale feature. So the other thing Clarity is very, very good at is the ability to overlay VPC Flow Log information. And so VPC Flow Logs are your firewall filter log as a service delivered to us by AWS. And as we check this box, we go out and we retrieve that information on demand. That's not some of the information that Dome9 stores locally. So it takes between 7 and 10 seconds to do so. And then when it's ready, you'll see these little red legends pop up on the bottom right-hand side of each security group within the Clarity illustration. And these little red legends have to do with how much dropped traffic each security has processed based on its rule set relative to the rest in this VPC. So if I'm doing a regular security review, for example, I can see that the monitoring security group has dropped less traffic than has common SG, for example. Or App1 service has dropped a little bit more traffic than monitoring has. And one of the curious questions I have when I look at this, these indicators is that I have something on the edge, default, and I have something tucked way back here, apparently in the internal private zone. Why is my private zone dropping more traffic than something publicly exposed on the edge? That doesn't make a lot of sense to me. It could be a misconfiguration. You know, maybe one of the tiers of my application I've configured to talk to my database servers, yet I haven't, you know, built the appropriate rule there so that, you know, I'm dropping a lot of traffic at the DB server's security group side. Or it could be something, you know, maybe malicious or not, something that needs a little more investigation than that. And so now I can click through, you know, for example, I can click in my default security group. I can work with this Explorer type interface, investigating the traffic, you know, supplied to me by AWS Flow Logs. And if you've worked with Flow Logs in their native format, they're not unlike any other firewall filter log, right? They're not all that human readable. They're not correlated by security group at all. This is all part of the magic that Clarity provides us. And so I can do things like, you know, understand from a geolocation perspective where this IP address belongs to. You know, I know no part of the Dome9 solution legitimately resides in Russia. This is probably something like a port scan attempt. And I can sort of walk down the line profiling each one of these access attempts and understand what it is. I can filter if I see an IP address one too many times. I can filter. The initial perspective is just to look at all of the rejected traffic based on your rule set. You know, many data security standards mandate that we must log and review at least the rejected traffic, but certainly, you know, if you're logging everything from a Flow Logs perspective at AWS, we can show you all of that. And for me, you know, showing both the accepted and rejected traffic paints more of an overall story around traffic, for example, right? I can see send and response pairs this way, accepted, rejected. To me, that's a bit more of a complete traffic story than just looking at the rejected traffic. But of course, there is a cost component to turning on Flow Logs and dumping that information to an S3 bucket, for example. So not everybody does that. So to answer this question around, you know, why do I have so much drop traffic at this database server level, even more than something that's at the edge of my network, we have a second view to Clarity. So right now we're looking at distinct security groups. If I pivot this view in the top right to what we call effective policy, we're going to look at something slightly different. And this is groups of common resource to security group assignment. And this can get a little bit technical, but let me walk you through it. What this box means, for example, is that I have one resource, namely an instance called App Server 1. Always look to the right-hand detail pane to get, you know, all the information you need. Assigned to a combination of two different security groups, namely App1 servers and common SG. Right, as we all know, you can have more than one assignment. One resource can be assigned to more than one security group, and that's what's happening here, and that's what this Clarity box tells us. This common assignment of two different security groups results in a cumulative or effective policy, the combinations of the rules in those two security groups listed here. So the effective policy is what this one resource, App1 server, you know, really enforces. And so now, with that information, I can see exactly what's going on. Back here in this DB server's grouping, I have two resources. Looks like one instance called DB2 and one RDS instance called MySQL RDS1, squarely assigned to the DB server security group. But then I have one resource over here in the DMZ assigned to both DB servers and default. And this is the culprit, right? Here I've got a nice, neat internal rule set, but over here I've got one that's assigned to DB servers, but also that pesky default security group, which we now know we really shouldn't have in this network at all, and certainly shouldn't have as a permissive rule as this, all access SSH rule. And so the second view, this effective policy view, made that painfully obvious for me, right? Right here in the DMZ, I've got this single resource assigned to 2 different security groups, and this is the culprit. This is why I have so much drop traffic among my database servers, especially, namely and more specifically DB1. So, I think about the first view we looked at, this security group view, as more of my architecture, how I want my VPC to behave, and then the effective policy as more the operational view, based on that resource to multi-security group assignment, what's actually going on in any given VPC. And so both views are important when doing regular security audits, or like we did, trying to understand context around failures coming out of the compliance engine, for example, trying to understand exactly why somebody might have done this in the first place, or if one of these offending conditions is serving a business purpose or not. Clarity is very, very good for that. In our case, what we would likely do as a next step is open up our default security group, clear it of rules, make sure that our database server is not assigned to that and is probably uniquely only assigned to DB servers. And that's a change we could effect very easily through Dome9. So then let's leave clarity, and I'll just do a little bit of cleanup for the next part of our demo, and let's go back to the compliance engine. We spent a long time on this example, but certainly the compliance engine found lots of deviances from our desired baseline, right? We found that one. We found that flow logging is not turned on everywhere, which really should be mandated. We found that a lot of other sort of network service violations. We found that some of our instances belong to EC2 Classic and not part of that more secure VPC-driven architecture, and a bunch of other checks associated with this PCI DSS assessment that we ran. And so part of this, and as we talk about the case for automated security, is that we came in and we triggered this assessment by hand. That's not the only way to do this, of course. As we talked about, everything that you see me do in the webinar this morning interactively can also be done by Dome9 API. And that's a really important tenet as we think about connecting this compliance and governance process to other automated actions within our environment, maybe like a CI/CD software publishing pipeline, for example. We may want to send a CloudFormation template into the compliance engine for assessment, and let me do that real quickly. I think I promised you earlier I would do that. Rather than judge, a live environment, let's feed a CloudFormation template in, and I will do so like this. And we're doing so against the PCI DSS rule bundle like we did before, except now we're evaluating a JSON formatted CloudFormation template. And now we get the results back against that, and it looks like we did a fair bit better than when we evaluated our live environment, right? Now we have a 92% pass-fail ratio, which is good. And so we'd iterate through this process until either we're at 100% or we're at a level that was organizationally, sort of appropriate for the next part of our process. And again, I did this interactively, but you could feed this in via API, get that CFT judged, and then sort of move further along in that CI/CD process. Maybe the next step would be to provision it through AWS. And then maybe once we're done, we want to trigger, a live assessment just to make sure that no changes snuck in between the CFT-defined environment and then the actual provisioned, within AWS or whatever cloud platform we're working in environment, right? And sometimes, depending on how secure your organizational process is and the time allotted between those two steps, we might want to do a check both against infrastructure as code and then against our live environment. And so that's a process easily achievable by by an API-driven nature through Dome9. So next, let's talk a little bit about, if you're not governed by a formal data security standard, or even if you are, but you want to augment that with, checks that might not be part of that standard, but are still organizationally important to you. Dome9 has a way of describing your own customized rules, and we do so in a language proprietary to Dome9 called GSL, and that stands for Governance Specification Language. And it is a near natural English language, certainly not a developer-centric kind of way to define rules. I just turned that GSL support on, and so you can see, for example, CloudTrail should have log file validation enabled equals true. That's the kind of rule, really easy to understand from a reading perspective, equally just about as straightforward to author. And the whole idea is to get the policy creator closer to be able to author his or her own rules, rather than having to lean on, again, that developer skill set to do so. Quite often, our experience has been that having to do that, having to sort of communicate the intent and the specifics around a desired measurement to a developer or a group of developers to write a rule, some of the intent can be lost. And so the idea is, again, to have a language where the policy creator can work right within Dome9 and maybe author their own rules. And I'll show you how that's done in just a moment. So the first thing to do if you're interested in customizing rules or writing your own is to either start with a bundle, and I could take PCI, I could clone it. Down below this little horizontal separator are all of the customized rule bundles that folks here at Dome9 have created, some by copying these bundles above and some by creating net new bundles. And so if we take a look at a copy of PCI, for example, now I can go in and I can augment these rules with conditions that are important to me, or write brand new rules. So for example, here's a rule that says, S3 buckets should have logging turned on, right? Should log to CloudTrail. This is certainly a best practice and something that PCI mandates, is that we should have no really access plane at all that isn't logged. So this one is checking S3 buckets. If I wanted to tweak this rule, maybe I wanted to assert for tag conditions, I could pop in here and actually work with the syntax of the rule. And if I know the GSL syntax, I could write it here. If I don't, I can lean on a Dome9 capability we have called the Rule Builder. And the Rule Builder sort of guides me through all of the services and conditions that Dome9 supports, and I can iteratively build a rule in a guided fashion. Let's ignore the S3 example for a minute, and let's write something a little bit different than that. Let's write a rule to do with identity and access management policy. So, for example, I might want to do, if I have something in mind to do with testing individual users or roles, I could use either the user or role or a group if that's kind of what I'm interested in measuring. If I'm more interested in measuring IAM policy at large, I can use this one. And let's say I want to know my IAM policy should have account MFA enabled, meaning I should mandate account-wide the use of multi-factor authentication. That's as easy as it is. I author the rule, I unit test it to make sure my syntax is right, and here within our demo Dome9 account, I have not. Right, my one account does not mandate account-wide MFA. Users might have it turned on for particular users, but from an account-wide perspective, I don't have account-wide MFA turned on. And so that's how straightforward it is to author a rule with GSL using the Dome9 Rule Builder. And we are sort of working within the context of a PCI rule bundle. We also have a playground up top where if you're not quite at that point yet, but you're interested in experimenting with rules. You can do the same thing and not be part of an existing bundle, right? Not be in a customizing kind of way, just working through the GSL syntax, making sure you understand it and building effective rules. Once you have something, you can always cut and paste and build it into a different rule. So that's how powerful it is to be able to, either take an off-the-shelf compliance standard that Dome9 supports out of the box, and or augment it with conditions that are important to you. For example, we looked at when we looked at failures from PCI, we looked at some of the network, port exposure kinds of failures, and I'm just scrolling down here to, yeah, these kinds. Now, no existing data security standard would know, for example, my tag conditions. So one of the ways we segregate or we measure the separation of networks that contain, PII, for example, from networks that don't, is by tagging them certain ways. And so I might want to say, okay, under a certain tag condition, my security group should never have really broad scopes. But in a separate network that is disconnected from all production data, I might not care as much. So maybe I want to say security groups with a specific tag condition should follow, should adhere to these rules, but security groups without shouldn't. That's very easy for me to do within GSL, right? So I can take an off-the-shelf data security standard that's pre-published by Dome9 and augment it with conditions that are appropriate for my context. No pre-published standard will obviously know your naming standards or your tagging standards, and so that's the power of being able to start with, a fully built-out pre-bundled set of rules, and then just tweak them and make them a little more specific for for your naming or tag standards, for example. So probably the last thing we should talk about from a compliance perspective is the ability to do auto remediation. We talked about, against the security group control plane, we talked about this notion of tamper protection earlier, where you can flip that switch for any given security group, saying, look, once I've got it dialed in exactly the way I want Dome9 to continually enforce this configuration. Within the compliance engine, you can do some automatic remediation as well. And to show you this, I'm just going to log out of this account and log into a different one. I'm going to pause the screen while I do that, just a moment. And we're going to talk about the ability to do some automatic remediation based on the findings of the compliance engine. Okay, I've reshared my screen out, and this is my personal account. You'll see why I'm using this one in a moment, not the demo account, because we're actually going to affect some change based on, again, the failures coming out of Dome9. So let's look at the compliance engine, and I have a very basic one rule bundle built, and this is a rule like we've already seen that says any instance, not security group in this case. So now what I'm doing is I'm measuring kind of the effective policy of any instance, obviously governed by security groups, should not have a broad kind of any allowance for traffic coming in on port 22, the SSH port. And you'll notice in the remediation steps, now I've got this tag that says auto, followed by a tag called stop instance. Now normally, not normally, often in remediation we'll have the English paragraph or a few sentences that speak about how to solve or how to remediate this particular rule. In this case now, we're actually leveraging some tags that signify to a project we have called Cloud Supervisor, and this is it here, that what we're about to specify is an action. Right? So any remediation field that starts with asterisk, auto asterisk, followed by the next action is an automatic remediation step towards the failures coming out of this rule. So let me show you when I run this bundle against my single AWS account I have connected here. I get failures. Out of 4 instances tested in my small sample account, I have 3 that failed, namely one called SI blog, one called Cloud Supervisor Test 1, and one called Cloud Supervisor Test 2. Now I ran this test in an ad hoc way interactively through Dome9. But the idea here is that through a project we have called Cloud Supervisor, you can call the Dome9 API, run a compliance test, and then again, the failures of each rule can be remediated in an automatic way. And the Cloud Supervisor project is an open source project. You actually load this into your AWS account yourself, which means you don't have to give Dome9 permission to change your environment. This is something that starts from your own account. And again, what it is it's a lambda function. It can be run from an independent host too, but it's an AWS lambda function which will call an API from Dome9 to launch into a compliance assessment, and then it'll wait for the results. And the results that come back, again, with a remediation that looks like this, we're going to carry out this action for each of the failed results of this rule. So for example, or said another way, every instance that fails this rule, we're going to call an action called stop instance, which, as you can imagine, is actually going to shut down the instance. So any instance that fails this, that does have very, very broad port policy to do with SSH, we're going to actively stop. All right, and if we look at the project here, there's a few actions that come stock with Cloud Supervisor. Stop instance is one of them. Create a tag. So maybe we want to conditionally tag all of those entities, whether they're instances or security groups or anything else, with a specific tag if they fail, and we'll go back in the future and remediate that. Or we have another process running in our environment already, which will look for these tags and somehow triage, you know, these resources. We can mark for stop, so we're not going to actively tear down a failed instance, but we're going to mark it for a stop later once we can go in and actively review. Or maybe we're going to send a custom SNS notification that's presumably maybe connected to our SIM tool to create a custom alert, right? Whereby our security operations or our network operations team will take corrective action themselves. Kind of varying levels of automation within your environment. But the Cloud Supervisor project can also be augmented with your own custom actions, right? You can build actions in JavaScript that carry out very customized actions within your environment that are important to you. This is what the project ships with, but customizing these is very, very straightforward. So what I'm going to do is I'm going to head into my AWS account. This is it here. This is the Cloud Supervisor project. And I'm going to be using rule bundle 7321. This is the rule bundle that I'm going to exercise. So if I go back to my, get out of here, if I go back to this rule bundle here, and if I look at the URL, indeed it is rule bundle 7321. Now this rule bundle only has one rule, right, to make this example very, very simple and straightforward. But I'm going to exercise this. And then really the Cloud Supervisor project should be waiting for failures, and then for any failures, for any instances that do, and we already ran this, so we know there are 3 instances in my account that do have very broad SSH, it's going to call the stop instance action, and it's going to actively shut these down for me on my behalf because they failed this check. So let's do that. Let's go ahead and run this Lambda function. Now I could tie this to a schedule. I could have this run, you know, every half hour, every 5 minutes, doesn't matter. I could tie this to a change window, right? Maybe at the end of a change window, I can run this kind of assessment to make sure that nothing was introduced that violated policy, for example. In this case, I'm just going to unit test it. I'm going to hit test, and I'm going to run the Lambda function. And over here, I can actively watch these 2 instances, which again do have a very permissive port policy against SSH. I can watch what happens. And if I refresh this, I can see now they're actually in the process of stopping. And just to kind of close the loop, I can see the execution finished. I know that because I can see them actively stopping now. But if we go and we look at the logging associated with Cloud Supervisor, and that is here, I can see exactly what happened. So we went out, we ran our assessment. I can see there was a rule violation. Instance should not have any rules that expose SSH to the world. And sure enough, I had 3 instances that did. One called SI blog, which is in another region, so you don't see it in my AWS console like you saw the other 2. And then one called CS test 1 and CS test 2. And so I had one failed test with auto remediation. So Cloud Supervisor actively shut those instances down using that stop instance action. So, you know, Cloud Supervisor is a way to leverage the Dome9 compliance engine and do some automatic remediation where it finds, you know, deviances from your policy. And it's a nice balance. I mean, we didn't talk about this at the outset, but when you onboard with Dome9, you can either give Dome9 the ability to just read your AWS account details, or you can give Dome9 the ability to read and write, right? So that features like tamper protection work. You know, when we do that automatic enforcement of your security group configuration, Dome9 obviously needs some, Dome9 needs some ability to go and change that security group rule set. So, for those functions to work, you have to be in read-write mode. But for Cloud Supervisor, because the whole process starts with your own AWS account, you don't need read-write mode. And it's a really nice balance of calling a read-only assessment through the Dome9 compliance and governance engine, but then affecting change through your own AWS credentials, starting with the lambda function. So in this way, you can get really, really really automated and tie the use of the Dome9 compliance engine to any existing process you might have within your organization. I think we're probably at the point where I should stop. We have about 5 minutes left, and let me just pivot back to the slideshow here. One moment. So to close, my goal has really been to illustrate for you some of the emerging trends insofar as infrastructure and security management and how Dome9 really tackles these problems, right? We've built in the solution to be as equally appropriate for the organization just beginning to migrate from the data center, in kind of a lift and shift sort of fashion, all the way to supporting the fast consuming and scaling sort of flagship customers you see at just about every AWS or Azure or GCP event. And for those who follow immutable infrastructure paradigms where problems might be triaged in production but are always fixed in code, think CloudFormation templates as we've talked about already. We talked about how both Dome9 Clarity and the compliance and governance engine support the upload of CloudFormation templates in an effort to analyze them from a security perspective very early on in the process, long before you would ever provision them, into actual network resources. And in general, the Dome9 API provides all the opportunity you need, to integrate anything with Dome9, but also to control Dome9 non-interactively. We talked about the use of Cloud Supervisor to do this as well. Kicking off a compliance assessment via API as part of an automated routine or a cron job, for example, it provides a point-in-time snapshot of your security posture. And Dome9 customers are doing all sorts of great things with the compliance engine, right? Regular assessments, conditional assessments based on scripted conditions, assessments in response to specific network events. Really, the sky's the limit in terms of flexibility provided by Dome9 and the use of the Dome9 API. So with that, I think we'll pause, and we don't have a lot of time left. Talon, do we have any questions that might be appropriate for 4 or 5 minutes?
We do. Thanks, Patrick. Yes, the first question we have is, does Clarity work only for AWS, or can I use it across Azure and GCP as well?
Great question. Clarity, just like really any Dome9 capability or feature, save for a few that are platform specific, does work equally well across AWS, Azure, and GCP. The compliance and governance engine does as well. We kind of followed an AWS use case as we talked about the compliance engine and failures and investigating those with Clarity, but it does work equally as well across all the platforms that Dome9 supports.
Great. And we have another question. Where can I find out more information regarding the Dome9 API?
Very good. I will paste a couple links here. Let me just pull that information up. I'll paste a couple links in the chat window that will provide that information for you. Let me just grab that here. Maybe telling if there's another question, let's go to that one, and I'll get those links pasted in the chat window right away.
Okay. Another question, how do I onboard my AWS to Dome9?
Oh, yes, we talked about that briefly. Really, you create, and I have the API links coming in the chat window now, but in terms of onboarding accounts to Dome9, whether it's an AWS or Azure or GCP account, the process is similar in theory. On AWS, you create a role and a policy, and you give Dome9 cross-account role access to leverage that that policy on your behalf. So no credential exchange. That's definitely the old way. We haven't done that in years. And in this way, you're really in the driver's seat in terms of what Dome9 can access. It's by specific name policy. So we ask for the ability to understand security groups, to understand your instance state, to look at your S3 bucket policies, for example, and all that's done via a very specific IAM policy and role. So yeah, very straightforward to do, and it's a guided process.
Okay, and one last question. With existing test suites that Dome9 offers, do folks have the ability to modify the existing suites like PCI DSS or HIPAA?
Right. Yeah, absolutely. So as we navigated through the compliance and governance engine, you can take them sort of off the shelf as they come in the pre-published format from Dome9 and execute them. That's kind of as intended. But you can also take them and clone them, and then that process makes them customizable. So you can add to them. If you like the tests associated with the PCI DSS test, for example, yet you're not specifically governed by PCI, you could take that bundle, clone it, delete the ones that maybe aren't appropriate for your environment, augment the leftover ones. Again, as I think I mentioned, with tag conventions or naming standards, that sort of thing. Yeah, the sky's the limit in terms of customizability. Really, either use it as it's in its pre-published state, or clone it and sort of tweak it until it represents really what you're interested in.
Great. All right. Well, thank you, Patrick. All right, everyone. This concludes today's webinar. Thank you for attending. If you have any further questions on the information presented today, please don't hesitate to reach out to us via the email q&anda@dome9.com. I have a few final notes. If you enjoyed the webinar presented today and would like to experience the Dome9 ARC platform for yourself, we are offering a 14-day free trial. Please visit our website at www.dome9.com and click on the Get Started button on our home page. Just register and a representative from Dome9 will contact you to activate your free trial. Additionally, if you liked the webinar today and would like to hear more about the multi-cloud security solutions Dome9 provides, please visit the resources page on our website and sign up for several of our upcoming webinars, or go to www.dome9.com/webinars. If there's a topic you would like us to discuss, please contact us through our website and let us know. With the end of this webinar, a copy will be provided to those that attended, as well as posted on our website. Give it about an hour and it will be on demand available for you. With that, we thank you for your time today and hope you found the content informative. This now concludes the Dome9 webinar. Enjoy the rest of your day.
Thanks, everybody.